Welcome to the fascinating world of outer space. Today we're going to tackle a topic that seems straight out of a science fiction story, but is just as controversial: terraforming, the process of making a planet suitable for human habitation. In particular, we'll discuss why Venus might be a better candidate for this process than Mars. If you're ready, let's start this space journey. Terraforming refers to changing the environmental conditions of a planet or satellite to make it an Earth-like habitat. This idea has long been popular with humanity's dream of creating new habitats in space. Mars and Venus, in particular, are the most talked about planets in this regard. However, this process raises not only scientific but also ethical and economic debates. So why is Venus, although often overshadowed by Mars, actually a better option? While Mars, with its red surface and water glaciers, is the first planet that comes to mind for terraforming, Venus has its own advantages. Real photos from the Venera program reveal Venus's surface filled with extreme heat and a dense atmosphere, a living hell. But these harsh conditions offer unexpected opportunities for terraforming. Let's explore why Venus is a better candidate than Mars with a narrative enriched by Venera photos. Venus's biggest problem is its thick and scorching atmosphere. The color panoramic photo taken by Venera 13 in 1982 shows a rocky surface full of cracks under a yellowish sky. With a temperature of 464 degrees Celsius and a pressure 92 times that of Earth, it is a wonder of nature. This image dramatically illustrates just how dense a layer of gas Venus is covered in. But this problem can be turned into an advantage. The first step to making Venus habitable is to freeze the atmosphere. We could do this by using huge reflective mirrors or canopies to block sunlight from the planet. The first surface image taken by Venera 9 in 1975 supports this idea. The gray barren landscape and blurred horizon show how the thick atmosphere scatters sunlight. Thus, these canopies cool Venus, allowing dense gases to become liquid or solid. Carbon dioxide freezes, the pressure decreases, and the surface is ready for transformation. On Mars, the opposite is true. The planet needs to be heated with enormous energy to thicken its thin atmosphere. Venera 14's 1982 photo shows that Venus, with its flat but hard rocks, already offers a solid foundation for this transformation. Compared to Mars, this process requires much less energy and can produce faster results. Venera photos, Venera 13's yellow sky and fractured terrain, Venera 9's evidence of a dense atmosphere, Venera 14's rugged surface image show that Venus provides a unique backdrop for terraforming. Cooling the atmosphere with canopies is simpler, more efficient, and more realistic than heating Mars. On Mars, the opposite is true. Mars's atmosphere is very thin and cold, so we need to use huge lasers or other energy-intensive methods to heat the planet and thicken the atmosphere. This is both energy expensive and can damage the planet's surface. So, in terms of atmosphere management, Venus has an advantage over Mars. By the time we start terraforming, these planets will probably already be inhabited by humans. On Mars, colonies will usually be established in low-altitude regions, for example in the Hellas Basin or Valle Marineris. However, if we terraform Mars, these regions could be covered by oceans and existing cities could be flooded. This could affect the lives of millions of people. On Venus, surface conditions are so hostile that no one would consider colonizing the surface. Instead, floating colonies in Venus's atmosphere are more likely. Terraforming could affect these floating colonies, but without the massive destruction of surface cities like on Mars. This makes Venus a less risky option for existing colonies. Venus's terraforming process is also more economically attractive. If you remember, the canopies we will use to cool Venus can also function as solar panels. These panels could not only support the terraforming process, but could also be used for other projects by converting sunlight into energy. For example, this energy could be used to build massive cooling towers to accelerate the cooling of Venus, or to transport water from the outer solar system. On Mars, there is no such economic return. Terraforming Mars would require an investment of trillions of dollars and could take centuries. Venus, on the other hand, has the potential to be self-financing thanks to its solar panels. In addition, the abundant nitrogen in Venus's atmosphere could be a valuable resource for nitrogen-deficient places like Mars or the Moon. Another challenge for Venus is the lack of water. While Mars has a small amount of water, Venus has almost none. However, this could actually create an opportunity. To bring water to Venus, we could import water from water-rich regions in the outer solar system, such as Ceres or Callisto. This could encourage the development of colonies in the outer solar system, as these colonies could become economically profitable by selling water to Venus. On Mars, there is no such economic incentive because Mars already has limited water resources. Of course, terraforming Venus is no easy task. After freezing the atmosphere, it will be necessary to remove these frozen gases from the planet. Biological processes must be initiated to make the remaining nitrogen-dominated atmosphere suitable for life. For example, plants or microorganisms would be used to balance the gases in the atmosphere. Another big problem with Venus is that it rotates very slowly. One Venus day is equivalent to 243 Earth days. This makes it difficult to keep the climate in balance. However, the shades we mentioned earlier can work here too. Canopies can simulate a 24-hour day by directing sunlight in accordance with the day and night cycle. Also, Venus has no magnetic field, but this problem could be solved by creating artificial magnetic fields. Instead of terraforming Venus or Mars, there is a more practical alternative: space habitats. These habitats, which could be built from asteroids, could house thousands of people. With the resources in the asteroid belt, we could build millions of habitats. This is a much cheaper and faster solution than terraforming a planet. In conclusion, while terraforming in general is a costly and controversial process, if we have to do it, Venus is a better candidate than Mars. The atmosphere is easier to manage, the impact on existing colonies is less, the economic returns are higher, and there is potential to revitalize the outer solar system. Perhaps one day there will be two Earth-like planets in our solar system, and this second Earth may not be Mars, but Venus. See you on the next adventure, and don't forget to look to the stars. For more of this kind of information, don't forget to subscribe and like our channel, and let's meet in the comments.